Hello everybody, my name is Kai and in this video series I'd like to teach you the basics of programming. A small warning for those of you who already know programming, I will simplify things quite a lot, even to a point where they're actually wrong. But I'm doing this because I think that beginners may find it easier to understand that way. Okay, today's topic is variables, and I guess you're not here to hear me talking, so let's get started. I guess that most of you have seen this before in one way or the other. This is a PC hard drive and PC memory, which is built into every PC, maybe looking a bit different, and maybe modern hard drives look different, but basically it's a hard drive and it's a piece of memory. And why I'm showing you this is because when your PC is shut down, it's powered off, it's not running, all the information that are stored are on the right side, on the hard disk. As soon as you start up your PC and it's getting power and it's starting to work, it's moving some of the information to the memory on the left side. And this is very important to understand because the variables that we are going to use today are in the memory, so on the left side. To show you what variables are, I'm using the programming language Java today, and we don't care about the programming language today, and we don't care about the stuff that is already written here. We will cover this topic later. Today we really just try to focus on the variables. So please try to ignore anything else and concentrate on the variables. I will need one thing here to show you first, and that's how you write a comment in a programming language, and it's like this, starting with 2 forward slashes. And a comment is just some human readable text that the PC, that the program will ignore when it's running. So it is just for us to write some notes, to write some information that we can work with or that we can read while we are reading the code. Okay, let's take a look at a variable. There are mainly 3 parts we need to take a look at, and I will write them down first. So let's say we want to have a number, and this number should only use integer values. That means values which are not float point values. So it's a 5, it's a 7, it's a 8, but it's not 5.0, 5.5, 6.7 whatsoever. So it's really just a integer number, and that's what this first part of the line means. This keyword int means in this variable we are storing only integer values. This is a variable name that we have come up with, so we can invent the variable name ourselves. So data type is the first part of this line, so the integer is the so-called data type. Then we've got the variable name that we can really invent ourselves. And on the right side we've got the value which will actually be stored in the variable, or the piece of memory this variable stands for. Before we take a closer look, let me just show you a few more variables, so you may get an idea that the scheme is always the same, and only very small things change here. Let's say we want to store a float point value, so we use a different data type, and we can give this one a name. Let's call it FL number, and I could store the 5.5 value in this variable because it's a float point variable, and the small f at the very end is necessary so the program knows that this is really a float point value. To simplify things, I will store the number 5 here as well, and let's just take a look at another variable that we could use. That would be a byte, and this is a rather small number which only has a very limited range of values available, but again I just store the 5 here in this one. Okay, now we need to understand what about this strange variable names that I just came up with. What is it all about? You may have seen this kind of error message on your PC. At least if you're a Windows user, you may have seen it once or twice, and it looks strange on the first strike, but it's very important to understand what's going on here and why this one is relevant for our variables. You may see that we have this strange number here, 0x00, I don't know, and so on. A very strange complex number, and this actually are the addresses of your memory. So your memory in your PC has a bunch of different addresses, a lot of numbers, quite strange looking numbers in a different kind of coding system. But we don't really want to work with these numbers, but the PC does. And variables will help us here because they allow us to use a human readable name to hide this very complex number that we don't want to keep in mind and to work with. So variables are actually our way to avoid working with these strange numbers and have easily readable code to understand what's going on. So maybe our variable called number actually is pointing to the memory address with this strange code. And we don't want to work with this. We would be very stressed if we need to memorize all these strange numbers, and they are very easy to misspell. And so this is what variables are for. Actually, our created variable called number is pointing to this address, but we don't need to memorize it. Let's talk about the variable names and how we could structure them. Actually, you are free in inventing any variable name. So you could write something like this. Of course, it does not make sense because this one would be hard to read as well, but you could. There are just a few rules that you should keep in mind while creating your variable names. First of all, variables should not start with a number because this would be a problem. In programming, it's not allowed that variables are starting with a number. Secondly, variables should not have spaces in between. So this variable would read number 1, but the space in between would be a problem to the PC. So what you use instead is you use this kind of underscores, but actually in anything else you are free to write your variable names whatever you want to. So this here would be a valid variable name, again a very strange one, but it would be allowed. Okay, let's stick with this one. And let's take a look at one very important fact here as well. I'm just copying the line. A variable name, of course, may only be used once because it's pointing to one piece of memory. So this is why this line gets underlined in red here, because the system already realizes there's a problem. I could go ahead and change this first letter to a capital N, and then the error is gone, and this one is allowed. It's allowed to use capital letters to avoid this conflict, but that's very important for you. These two variables now point to different pieces of memory. So maybe this one is pointing to a memory block ending with 3A. Okay, they're reading the same for human, but for the PC they are totally different because there's just a change in the capital writing. So variable names, usually in most programming languages, are case sensitive. It matters if you spell them in capital letters or in small letters. Okay, let's get rid of this variable here again, and let me show you just a few more variable types, some data types that you should know. We also have a so-called double variable, which somehow is a big float point value. But big maybe not the right word here, because actually, first of all, I should spell it correct, but actually doubles are very good in showing very small numbers. So for example, 0.0000 and then something else. So there are a lot of float point values in a very small manner. But of course you could put very big numbers in this one as well if you like to. Okay, but again, for showing you something else, I will stick with the number 5 here because again, this is valid. Let me show you a data type which allows you to store a character, a single letter. This would be the data type char for character. And again, I will put the 5 here. And you may now realize, okay, this is strange. I'm using a letter 5, a character 5. This is not the number, this is a letter. So this is really tricky when it comes to programming. Programming really knows the number 5 in many different variations, but it also knows the letter 5. And this may really become tricky at some point because programs really freak out if you mismatch the number with the letter 5, and this may really cause you some trouble. But let's take a look at one more other data type that we should know, and this one is called string, and this one is for any kind of text you want to have in your program. And so here we can write hello world whatsoever. We can just put text into this one, and in programming usually any kind of text is enclosed in these symbols here. Okay, but again, to show you something, I will put the number 5 here as well. And I said number 5, but actually this is the letter 5, the character 5. Okay, what is this all good for? Why do we need these variables? Of course we need them because we want to work with the values that we've stored in the memory. Let me just give you a simple example here as well. I'm creating a new variable for a result, and I will set it to 0 initially. So I just reserved some piece of memory and I placed the integer value of 0 in it. Let's come up with a different integer number 1. I'm using very short variables right now, and just another integer variable number 2. And I put a 10 in there. What I want now the program to do is really do some calculations for me. So I tell him, go to the piece of memory which hides behind the variable name res for result, and start calculating. And what should you calculate? You should take the information which is written in the memory at the place where the variable n1 is pointing to, and you should add the value of the variable n2 to it. And again, when this is processed, we get the number 15, and this number 15 then is written into the piece of memory where the variable res is pointing to. Okay, let me show you this one. I guess I need a bit more code now, which you should not care about. It's just code to show stuff on the screen, so we get an idea that this is working. System out print line. This one allows me just to show something on the screen, and I will show the value of the piece of memory behind the variable res before the calculation, and again after the calculation, so we see a difference. Let's see what happens if we run this one. Okay, and this is what we get. This output here shows us the 0, because before the calculation is going on, we have put the 0 into the piece of memory where the variable res is pointing to. And after this calculation, where we added 5 and 10, and we output the value, we get the 15, which is now in the piece of memory where the variable res is pointing to. So this is actually what we do with variables when we are working. We're just grabbing some piece of memory, grabbing another piece of memory, working with it, and mostly storing the information again in a third piece of memory to go on working with it later. And actually this is what we wanted to see today when it comes to variables. So we can define different variables at any time if we want to. We can give them names which make sense to us, and they should make sense to someone else reading your code as well. And we have these different data types which really just determine what should be stored in this piece of memory. Is it an integer value? Is it a float point value? Is it just a character, or is it a text? And we can use this information to let the PC do some calculations, output it on the screen or something else. Of course, we will use these variables over and over again in the upcoming videos, but for today, this should be all you need to know. Okay, that's it for today. That's it for variables so far. In the next video, we will talk about if-else statements, which allow us to send the code one way or the other. And yeah, hopefully this video will be out soon. Thank you for watching today.